Pydantic AI's toolset filtering mechanism lets you control which functions an agent can see at runtime by wrapping a toolset and evaluating a predicate against each tool definition. In the code below, a combined collection of weather and datetime tools is passed through a filter that excludes any tool whose name contains the substring Fahrenheit, leaving only the Celsius temperature, conditions, and datetime tools available to the model. The setup constructs a test model, applies the filter to the combined toolset via the filtered method with a lambda that inspects tooldef name, then registers the resulting toolset on an agent and runs it synchronously to query available tools, printing the names that the model observed.
From Pydantic AI Import Agent. From Pydantic, AI Models, Test Import Test Model. From CombinedToolset Import CombinedToolset. Filtered toolset equals combined toolset. Filter red lambda CTX, tooldef. Fahrenheit not in tooldef name. Test model equals test model #1. Agent equals agentist model. Toolsets equals filtered toolset. Result equals agent. Run sync what tools are available. Print T. Name for T in test model last model request parameters function tools. Weather temperature Celsius. Weather conditions. Datetime now.
The code composes multiple toolsets into one via CombinedToolset, then filters which tools are exposed to the model using filtered. The lambda checks each tooldef name and excludes any tool containing Fahrenheit, effectively stripping out the Fahrenheit temperature tool while keeping Celsius and other tools. The filtered toolset is registered on the agent at construction time via the toolsets argument. This pattern lets you declaratively prune tool availability without modifying the underlying toolsets. The filter runs per step, so it can adapt based on run context if needed. Trade-off is the filter is evaluated at runtime per step rather than statically, which adds a small overhead but enables context-aware gating. For production, keep filters simple to avoid surprising the model mid-conversation. Let's break it down.
From Pydantic AI Import Agent. From Pydantic, AI Models, Test Import Test Model.
Imports the agent class and test model from the Pydantic AI framework for creating and testing agents.
Filtered toolset equals combined toolset. Filter red lambda CTX, tooldef. Fahrenheit not in tooldef name.
Filters CombinedToolset by removing any tool whose name contains Fahrenheit and assigns the result to filtered toolset.
Test model equals test model #1.
Instantiates a test model object and assigns it to the variable test model.
Agent equals agentist model. Toolsets equals filtered toolset.
Creates an agent instance assigned to agent, initialized with test model as the model and filtered toolset as the sole toolset.
Result equals agent. Run sync what tools are available.
Calls the agent synchronously with the query, what tools are available, and stores the returned run result in result.
Print T. Name for T in test model last model request parameters function tools. Weather temperature Celsius. Weather conditions. Datetime now.
Prints the names of the function tools from the last model request, 3 tool identifiers, weather temperature Celsius, weather conditions, and datetime now. The filtered call on a combined toolset is the linchpin here. It takes the full collection of weather and datetime tools and prunes out anything whose name carries Fahrenheit, leaving the model only weather temperature Celsius, weather conditions, and datetime now. That filtered toolset gets registered on the agent at construction time via the toolset's argument, and when RunSync fires the query, the model sees exactly those 3 tools. The whole flow is declarative. You never touch the underlying tool definitions, and the filter reevaluates each step, so it can adapt if you wire in a run context, though that flexibility comes with runtime overhead. The takeaway: prune tool visibility at the boundary where the agent meets the model, keep the filter simple so the model isn't surprised mid-conversation, and let the predicate do the selective work.
The lambda wanders through every tool name, and Fahrenheit dissolves into Celsius, whether datetime now